This video will talk about the first model of a nuclear weapon, the atomic bomb type cannon Mark I, also known as Little Boy. The Little Boy was developed in the USA in early 1945 at the Islamic National Laboratory, as a result of the activities of the Grand Manhattan Project. The idea of this bomb was that if two halves of the subcritical mass of uranium-235 were quickly joined, then the mass would become supercritical. This will cause a chain of fission reactions. The process of splitting in a short period of time releases an enormous amount of energy, which is transformed into an explosion of great force, a nuclear explosion. The bomb got its name from the appearance, narrow-stretched ballistic body. It is 3 meters long, 71 centimeter wide. The weight of the bomb was almost 4.5 tons. Inside it was a 2-meter smoothbore gun caliber 160 mm, cast from steel at the naval factory. On both ends of the gun were 2 parts of highly enriched uranium-235, conditionally named shell and target. The shell consisted of 9 tightly compressed rings, each 159 mm in diameter, with an internal diameter of 100 mm. The length of the projectile is 180 mm and the weight 38.5 kilograms. The target was similar in design. 6 thicker rings, but a smaller diameter of 100 mm, internal diameter 25 mm. The target length is the same as the shell, 180 mm, and weighs 25.5 kilograms. The assembly in the form of rings created gaps, which gave the separating material as little contact with itself as possible, and the internal cavity allowed the emitted neutron to disperse freely, maintaining the assembly in a subcritical state. The target was fixed with a steel rod, clamped by nuts at both ends inside a shell of carbide tungsten, which plays the role of a neutron reflector, or tempera. This tempera was also surrounded by a steel shell reinforcing structure. The projectile was attached to a carbide tungsten disc, which in turn was attached to a steel cob. 4 packets of cardite powder with a total weight of about 3.5 kilograms were placed in the shell part of the gun. On the signal of a radio totem-air, at a given altitude, there was an explosion of cardite powder, which fired a projectile, driving it to 300 meters per second over 1,000 kilometers per hour. Upon approaching each other at a distance of about 25 centimeters, free neutrons began to penetrate into the assembly, making it critical, and if the speed of dispersal of the projectile was insufficient, instead of nuclear explosion could be obtained cotton. Approximately 10 milliseconds after firing, the projectile landed tightly in the target, simultaneously squeezing the initiator neutrons, releasing additional neutrons, followed by a fission chain reaction that occurred and was fully completed in less than 1,000 nanoseconds, or for 1/1,000,000th of a second. For example, for such a short period of time the projectile can fly only 0.3 millimeters. A free neutron, colliding with the nucleus of matter, splits it into 2 pieces, releasing kinetic energy and 2 or 3 neutrons each. The released neutrons repeated this process again and again, creating a dividing chain. The walls of the CBL absorber reflected the neutrons back, preventing them from flying away, which intensified the reaction. The design of the bomb was provided with 3 stages of protection against premature action, however it was very unreliable. Any fire, such as that caused by the crash of a carrier plane, could cause a cardite detonation and thus a nuclear explosion. Moreover, the fall of a bomb into the water, for example into the ocean, was also dangerous because the water would act as a neutron retardant, which could cause cotton with subsequent radioactive contamination. 64 kilograms of uranium were deposited in the Little Boy, but only about 600 grams, that is less than 1%, participated directly in the chain reaction. The rest of the uranium was simply dispersed in the atmosphere. In an implosive-type nuclear bomb, the baby's fat brother was laid 10 times less, only 6.5 kilograms of cheaper plutonium. Of this mass in the reaction involved more than 1 kilogram, that is about 15%, to the same powerful explosion fat was more. That's why the baby was recognized expensive and ineffective bomb unlike his brother.